Hello and welcome to Backbenchers Tution. This is Rakibul and today we are going to talk about parallel DC circuit. On my previous video I have talked about the series DC circuit and today we are going to talk about parallel DC circuit. So parallel DC circuit is that kind of network where a couple of resistors connected with nodes. Okay, I will let me first draw a circuit. Okay, let's see, this is the voltage source and let's set here. Here's a resistor R1, R2 and R3 and this is the node, the one. We can call it node 1 and node 2. Now what is the difference between node and wire? As you can see, this is a wire. Okay, so on this wire the current is flowing and it is the same, but when it's come to a node, as you can see it's a node. Now this is the node and the current is divided here. So we can call the blue current is equal to this 2 red current. Okay, we will discuss it about on the KCL. Okay, it is actually the Kirchhoff's current law. Okay, we will discuss about the KCL. Now the point is, on a parallel DC circuit the current is not the same as series DC circuit. The current can be changed, like as you can see over here, the current is getting divided and over here too. So parallel DC circuit, on a parallel DC circuit the currents get divided. Now as you know, on a series DC circuit the voltage is changeable but the current is the same because of a single wire, but it is not like that. It is the opposite of series DC circuit. Over here the currents can be changed and the voltage is always same. So over here the voltage is V1, over here the voltage is V2 and over here the voltage is V3. On a parallel DC circuit V1 equals to V2 equals to V3. Okay, that means V which is the source voltage E, so we can call this E. Okay, so to solve parallel DC circuits problems, like we got some problems like to find the total resistance, the source current of this network and the branch currents on each resistors or something. Okay, so let's get started. To find the total resistance of parallel DC circuits we will use this formula: 1 by RT, which is the total resistance, equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus dot plus 1 by Rn. You can see this infinite resistors. For these circuits we are going to use this, as you can see over here there are 3 resistors. So this is the formula to find the total resistance on a parallel DC circuits. Okay, now as you know the voltage on each resistor is same. That means this is E, the voltage for this R2 resistor is E and the voltage for this R3 resistor is E, I mean the source voltage. So if we want to find the source current, we just need to use the Ohm's law. Ohm's law, where is it? Ohm's law, V equals to IR, and the Ohm's law says the current is equals to V by R. Now V, which is the source voltage, and R, which is the total resistance. we will get the total resistance over here, and we have the source voltage E. Now we will easily find the source current on a parallel DC circuits. Now the point is, we need to find the branch current. To find the branch current, we can easily use the Ohm's law again. You can see, to find the branch current is here, the branch voltage is V1, which is E, and the total and the resistor, which is R1. So we can easily find the branch current for I1. Let's just say the branch current is I1. We can divide by V1 by R1. Or we can use the Kirchhoff. We can use the current divided rule, KDR. On a series DC circuit, we have talked about the voltage divided rule, and we are gonna, on a parallel DC circuits, we are gonna talk about the current divided rule. Okay. The current divided rule is very simple and easy, which is, let's just say current is IN. We are gonna find the N. We are gonna find the branch N, which is current. So IN will be like RT, which is the total resistance, divided by RN, that's the resistance of this branch, and the source current. So this is the current divided rule. We are gonna apply it on a mathematical problem, and then you will be able to understand. Okay, let's just say where is the mathematical problem. So as you can see, to find the total resistance, we are gonna use this. To find the source current, we are gonna use this, and to find the branch currents, we are gonna use this or this. We can use any one of this. We'll get the same result. Okay, now let's just solve the problem. Okay, so we got a problem over here. We got 3 resistors, a source voltage, and it says, for this network, calculate the total resistance. Okay, so for this network, calculate total resistance. Let's just calculate. Okay, well, as you can see here, there's a 3 resistors. We can put them on the formula. 1 by RT is equals to 1 R1 R2 1 over R3. Okay, so let's just put these values. 10 ohms plus 100. 1K means 1000 ohms. So let's just put this value in the calculator. That's too easy. 10 plus 1 over 100. 1000. Okay. It says, okay. Now as you can see, this is the one RT. Now if we want to find the RT's easy mathematical problems, that will be like, and now inverse, and which is the 9.009 ohms. We got the total resistance. Now we can draw a circuit like that with our total resistance, which will be like this. This is the source voltage E, and this is the total resistance RT, which is 9.009, and it is 24. As you can see, it's a very simple circuit, and we can easily find the source current from here. See, now we are going to use this formula. It's a very simple circuit, right? Okay, now you're gonna use this formula. So received it. As you can see, we got the E. Ohm's law says V equals to IR. That means I equals to E by RT. Sorry, excuse me. I equals to E by R. Now, the E is, we got the value of E. Sorry, excuse me. We get the value of E, which is 24 volt, and we get the value of RT, which is 9.009 ohms. Put these values in the calculator. 24 divided 9.009, okay, which is 2.664 amps. We got the source current already. This is the source current, IS. Okay, now we got the total resistance, we got the source current. Now they say determine the current through each branch. That means current flowing on this branch and this branch and this branch. We can indicate this I1, this I2, and this I3. Now we are gonna measure this current. We can easily use the Ohm's law to find the current, because on a parallel these circuits we know the voltage on each resistor is the same, which is E. Over here the voltage is E, and over here the voltage is E. Okay, let's just solve it. So the I1 will be E over R1. The E will be 24 and R1, which is 10 ohms. Okay, the I2 will be E over R2, which is 24 volts over 100 ohms, and I3 will be E over R3, which is 24 volts divided 1000 ohms. Okay, let's just put the values in the calculator. 24 over 10, which is 2.4 amps. Now 24 over 100, which is 0.24 amps, and 24 over 1000, which is 0.024 amps. As you can see, we already find the branch currents. Now we are gonna we don't know if this answer is right or wrong, so we are gonna check the value. So as you can see, on this network the current IS, which is, we have here 2.664 amps, anyways 664 amps. So, and this current get divided into I1, I2, and I3. So the sum of these three currents will be IS. This, okay, let's just check it, and if this is right, our maths will be okay. So IS will be I1 plus I2 plus I3. This is just, we are just checking the value, guys. This is not that necessary. So I1, which is 2.4 volt, and the I2 is 0.24 volt, and the I3 is 0.024, sorry, amps actually, sorry. So as you can see, we got the values 664 amps. That means our math is right. Okay, it was, we just solved it by the Ohm's law. We can solve it by the current divided rule though. Okay, so let's just solve it again with the current divided rule. Okay, so we know the current divided rule says IN equals to RT divided RN in IS, source current. So IN, now we are going to find the branch current I1, that will be RT divided by R1 IS. So the will be RT, which is RT just over here the RT is 9.009 ohms divided by R1 which is, we know R1 is 10, IS which is the 2.664. now put this value in this calculator. 9.009 over 10, 2.664. As you can see, we got the value 2.39, which is 2.4. Now it's time for I2. That will be like RT over R2 into IS, which is 9.009 over 100, 2.664. Let's just put this values. Okay, which is 0.239, which is 0.24. Now the I3, RT over R3 into IS, so that will be 2.664. So excuse me, which is 0.0239, which is 0.024 amps. Never forget the units. As you can see, the results are the same. So you guys, you can use any method for these problems, but this is a very simple circuit only with the parallel network, so you can use the Ohm's law. But if there's a complex circuits like series, parallel, or any kind of problems like that, then we can't use only the Ohm's law. Then we need to use the current divided rule and voltage divided rule. Okay, so in my next class I'm gonna talk about the series parallel DC, which is the complex circuit. So I think today's class was pretty much helpful, so please do subscribe and don't forget to share. And if you got any problems, just comment me below. And have a nice day, and I'm out.